This session is being hosted in collaboration with Coursera by Jindal Global Business School, one of India's leading private business schools and part of Jindal Global University, an institute of eminence. JGBS is double ACSP accredited, placing it among the world's top 6% of business schools, a testament to its commitment to academic excellence, impactful research, and global standards of business education. With over 170 faculty members, 200 plus international collaborations, and more than 1,350 Scopus Index publications since 2021, JGBS has built a strong reputation for integrating research, technology, and pedagogy. The school's mission is to create future-ready professionals by imparting interdisciplinary, experimental, and globally oriented education, and by fostering meaningful industry and academic partnerships. I am Professor Sharikat Das, your moderator for today's session. I am delighted to be joined by two of my distinguished colleagues who bring both depth of scholarship and practical industry expertise to this topic. Let me first introduce our panelists for today. Dr. Mohit Bhatnagar is an associate professor in the Information Systems and Analytics area at JGPS. He holds a PhD in Decision Sciences from Indian Institute of Management, Lucknow, an MBA from IIM Bangalore, and a BTech in Electronics and Communication from IIT Roorkee. Professor Bhatnagar has a rich blend of academic and industry experience, having worked across software development, program management, consulting, and analytics roles in the IT and ITES sector. He is also the founder of tucareers.com, an edtech venture that applies data analytics for career and decision support used globally by students and professionals. His current research focuses on the application of data analytics and natural language processing in decision support systems, with ongoing work in areas such as sports analytics and judicial data analysis. Dr. Pulkit Tiwari serves as an assistant professor specializing in information systems at Jindal Global Business School. He completed his doctoral degree from Bharati School of Telecommunication Technology and Management, Indian Institute of Technology, Delhi. His educational background includes an industrial MTech degree specializing in high performance computing solutions from CDAC, ACTS Pune, as well as a bachelor's degree in computer science from ABSS Institute of Technology in Meerut. During his PhD research, he developed a technological framework dedicated to smart cities, conducted an analysis of the current state of smart city development in India, and designed a decision support system for smart cities to enhance transportation and supply chain processes. So welcome, professors. It's wonderful to have you both here for this discussion. To the participants, welcome to this wonderful session. We will have the question answer session at the last. So first we will begin with the discussion. Please bear with us. At the end of the session, we will have the question answers. So big data is at the heart of every modern enterprise, from managing customer experiences and optimizing operations to driving innovation. The opportunities are vast, but so are the challenges. Data privacy, scalability, governance, skill gaps. So today's session will help us understand how enterprises navigate this evolving landscape, what technological powered the systems, and what opportunities await future professionals in this space. So let us begin the discussion with Professor Pulkit. Let's start with the fundamentals. Could you kindly explain what we really mean by big data? Over to you, Professor.
Okay, thank you, Professor. Professor, as the name suggests, big data deals with the huge amount of data, large volume of data that cannot be processed using traditional database techniques. But in other words, we can say big data is a collection of large, diverse, and fast-changing data sets. Okay, that can be analyzed computationally to reveal the hidden patterns within the data set, to identify the trends and the association most likely, especially relating to the you can say the human behavior and the interactions. It is we cannot say it is not just about the size of the data. On the basis of size of the data, we cannot say that is the big data considered into the category of big data. We also have to consider some other point also, how it is generated, how is stored, processed, and used to gain insights from the data set. So there are some characteristics of big data. Like first characteristic is the volume. Volumes deals with the use, the amount of data that is collected. Okay, so like data generated in terabytes, petabytes, and more. Like for example, that we in our daily life, we all use the social media platforms. Like data collected from social media post, from IoT sensor devices, and financial transactions. Second characteristics of big data is the velocity. The speed velocity deals with the speed at which the data is created, collected, and processed. For example, the for the velocity, the real-time streaming data from the stock market or online advertisement, online ads. Third characteristic is the variety, the types of data format, whether it is structured, unstructured, semi-structured, or for example, the data collected in the form of text, images, video, audio, logs, sensor data. So this is the these are three types, three characteristics. Apart from that, there are some more characteristics like veracity that deals with the accuracy, trustworthiness of the data. For example, you can say filter out fake reviews, unreliable sensors reading, and when we talk about the industry, like so the job of industry is to gain some value, to get some value. So most important property in terms of industry, the value, the usefulness of the data, okay, in generating insights or making decisions. So industry use the data analytics to optimize supply chains, predict customer behavior. So this is about the basics of big data. We can collect that big data from various sources like social media platform like Facebook, Twitter, okay, Instagram, some e-commerce platform also. From the e-commerce platform, from healthcare, we can use the big data in various sectors. Social media, e-commerce, healthcare, finance, in smart cities. So this is the about the basics of big data.
Okay. Thank you, Professor Pulkit. We often hear about the V's. Thank you for explaining volume, velocity, and how these characteristics are shaping the way organizations design and manage their data in their ecosystem today. So now coming to Professor Mohit, could you walk us through how big data technologies have evolved over time from the traditional databases to the distributed frameworks and now to AI-driven systems?
Okay. Thank you, Professor Saikat, and thank you, Professor Pulkit, for a very detailed introduction. So, I mean, I'll just start with like something called the Parkinson's law. So, the Parkinson's law, the first law states that like work occupies the time you have, right? So, similarly, it's the same for data. I mean, data kind of the way the background of the way data, what big data is, has evolved over decades, right? So earlier in 1960s, 70s, probably the amount of data at that point was much less, but we were still talking about big data. So it's not something new, but I would say like the real evolution of big data platforms came around the time when internet took off. So you're talking about the late 1990s, etc., when Hotmail was there. So that's when we started talking about data at volumes which were like much larger than what we have seen earlier. And at that time, I mean, that the cost of saving data kind of from like on a printed media to a digital device, it was very high at that point. I mean, we're talking about a few dollars, like probably $10 for a gigabyte of data. So at that point, when this cost of saving data on digital platforms significantly reduced. That's the way, I mean, that's, you can think of that as the starting of the journey. So probably early 2000s is when Google released its papers on MapReduce, which is a paradigm for parallel processing, and how they used to save the files for the primarily these are like large internet search engines which have to kind of save a lot of data across, so very voluminous data. So this is the point around which like the data processing of how we can actually work on in parallel on multiple, like on very large data sets, and could draw insights for them, is that's when this use started. So early 2000s is around 2005 is when duck cutting kind of came up with this concept of Hadoop. So they were working at Yahoo, and that's when this concept of concepts of big data platforms for processing these large voluminous items kind of took off. So since 2005, I mean, then around 2009, 2010, there was a new technology called Spark, which came up, which kind of talked about in-memory processing. So earlier, these things you could think of like as hard drives coming together and saving the data, but the processing was not so fast. But you were talking about applications where you had to draw insights about some applications over like your throughput was important, not like real-time processing. So that's when Hadoop came in, but Spark kind of changed the paradigm when we're talking about in-memory processing and very fast insights. So you were talking about drawing large insights from at a very in at microsecond kind of timelines. And since then, I mean, there's been evolution of this technology all along. So now we're at where we are talking about platforms where so all of these and just one big very important point is that in 2000 onwards there have been several technological changes which have led to kind of uh, large volumes of data being generated. So like think of how mobile phones came up, and then we had this Internet of Things. We had social media platforms. People could generate data themselves. So these techno, and then finally cloud computing, which has been like the probably the biggest driver when like the cost of saving data came down from $10 per GB to like or now almost a cent for like saving gigabits data. So that's the evolution. And now finally we have got these all these generative AI applications which are kind of very synergetic with big data platforms, because we're talking about drawing insights from very large data sets and probably taking it to the next level. So that's the overall journey in terms of how the technology has evolved.
Yeah, thank you, Professor Mohit, for explaining the major shifts in this journey. That sets a great background. So let's bring this discussion closer to practice. So, Professor Mohit, you have been doing fascinating work using analytics in domains like sports and judicial systems. So could you share what insights these projects revealed and how big data techniques helped uncover patterns in such complex areas?
Okay, thanks for asking. I mean, that's something very close to me. I've been working on this for the past 2, 3 years. So one of the things which India faces is a lot of pendency, as in like judiciary is there's lots of cases which have piled up over the years in India. So one of the things which I've been working on is kind of looking at, there's been a data set, large data set generated by a few people who have kind of scraped around 80 million cases across a decade of across a decade across courts, lower courts in India. So we've been trying to put together a model so that we can probably predict the duration and the pendency, like whether a case, if it's filed in a particular district, whatever court, can we predict that what amount of delay which it will take. So this involves like a lot of data engineering work in terms of getting this data set right, and then finally there is machine learning which is involved in terms of building models at scale, where you have to like say these, when you're talking about 80 million cases, if you try to work on a like say a laptop, you will not be able to kind of load these things into the RAM of the machine. So you need very high end processing for that. So that's where I've been working on kind of putting together a framework where we can explain. So explainability is another big challenge in big data. So been working on explainability as to how we can predict what delays a case would take when there, and it needs a lot of working with tools like Spark, etc., which I introduced in my introduction, where we need to draw insights from these or do use data engineering to make these make this data useful for analysis. So that's one thing. And the other thing which we were talking about in sports, so I'm very fond of cricket. Cricket is a very popular game in India, and Dream 11 is a very popular fantasy platform in India. So one of the projects which I've been involved in is to kind of draw insights from how people make their Dream 11 teams on this platform. So when we are talking about Dream 11 platform, it has like typically around 12 million teams which people make on a daily game basis, right? So even in larger, like in very popular, like say finals, etc., you have people making teams which are few million. So drawing insights from them and looking at the wisdom of crowds as to, if suppose if I were to look at what the overall opinion about the what's the probably likely best 11 which will win. So there can be a lot of work around wisdom of crowds which has been there, where if they say that if there's a group of people, they come together, they can draw insights from a situation very easily. They can predict that situation. So I've been trying to do that analysis on this large voluminous data. So we're talking about around 500 million teams, 500 million entries, which we have tried to look at through sampling, etc., and trying to draw insights from them. So these are the two works where I've been involved with big data.
That's great, Professor. Meaning, given the magnitude and volume of the data, no traditional technology can actually handle this. And also the areas like judicial system, it's a huge impact you are doing through your work. So thank you for explaining that. So now coming to Professor Pulkit, you have applied big data in the context of smart cities and financial decision systems. So could you kindly describe how data frameworks and like tools contributed to building actionable decision support systems in your
Okay,
research?
okay, thanks, Professor. When we talk about like a smart city in current scenario, it is the, you can say, a buzzword or a hot topic. So like people like to move from small towns to the large cities. So there is a requirement for urban development. And but in the if we, the people move from a small city to large city, so they consume the natural resources, and those are available in a limited amount. So it is most important to consider the use of a smart city, so that they can easily able to uh, maintain the development of the city as well as maintain the natural resources, sustain, you can say, sustainable development. And a smart city is also having resilience ability. So a smart city, in a smart city, there is a use of technologies like sensors, data analytics to enhance the city services, which help in improving the quality of life of the citizens and optimize the resources. Big data in terms of a smart city, you can say in this concept, big data act as a brain behind it that is used to collect, analyze data from millions of devices, and from the apps that used by the citizens of the city. So big data in used in smart cities in various applications in various areas like traffic management. With the help of big data, you can monitor vehicle movement, predict congestions to optimize signal timing. One of the example is the Barcelona traffic system, Singapore smart traffic lights. Second application is the public transportation, analyze passenger data to improve the routes and reduce wait times. One of the example is Delhi Metro smart card analytics. Another area we can use big data is the environment and pollution. We can use the sensors to track air quality index, noise, waste management. One of the example is Beijing air quality monitoring system. And in energy management also, we can use the big data, like collect data from the power sector to manage smart grids and reduce waste. So in Delhi, the Tata Power also use the big data for managing their smart grid lamps. Water management, we can detect the leakage and manage water distribution efficiently. In public sector, we can use the CCTV and real-time data for crime prediction and emergency responses. In healthcare sector also, we can use the big data to track the public health data to predict outbreaks and the plan resources. So these are the areas where in we can use the big data in a smart city.
Thank you, Professor Wilkit, for explaining so well the different applications of big data in the context of smart city. And that also actually give us this idea that big data is not just about volume, but as you mentioned earlier, it's about the velocity and the variety of data which gets generated and which needs to be processed. Like you mentioned in a smart city context, data is being continuously generated by multiple sensors and which has to be integrated and then analyzed and processed. So now, Professor Pulkit, let's turn towards the technology itself. So
Okay.
could you help us understand how big data infrastructure has evolved, like starting with Hadoop, which Professor Mohit mentioned, which pioneered the distributed storage and processing, to newer platforms such as Apache Spark and Databricks that bring cloud scalability, real-time processing, and integrated AI capabilities. Also, how do these newer tools address the limitations of RDS systems and how are enterprises leveraging them? Could you please explain?
Okay. Thanks, Professor. Before big data platform like Hadoop, Spark, data was smaller. Data was smaller and collected in a structured form of data that is stored with the help of traditional database and processed with the older systems like RDBMS. Okay, like for example, Oracle, MySQL. So they have the features to manage to use the structure tables, rows, and columns, SQL structure query languages, but they have the limitations about the about scalability for massive and unstructured data. Okay, they could not efficiently handle the huge volume of data and velocity that the data is having these properties like big data. So and some apart from our DBMS, there is OLAP, other techniques like traditional ETL tools, and but they were not easily able to handle the data that is having the huge volume, variety, and different kinds of data. So, with the modern technology, you can say with the rise of the modern technology like social media platform, IoT, cloud computing, new technologies were introduced to process these kind of data. To process this massive amount of data and that drive at a very faster rate. Like one of them is the Hadoop. So you can say that is used for distributed data processing framework. So one of the example is Apache Hadoop. Hadoop process the data in the using a batch processing technique using SDFS, Hadoop Distributed File System, and some other Hadoop, Apache Hadoop is the framework that is designed by the organization named Apache. Some other frameworks like Apache Spark that are faster in memory processing for real-time analysis. Apache Flink, Storm, so streaming data processing. But Hadoop is one of the most common, okay, we can say most important when the name comes big data, then people like to learn about the ask the question what is Hadoop. So Hadoop is the most you can say most famous, most important technology in the world of big data. The main advantage of Hadoop, it is the open source framework. Okay, that allows the organization to store, process massive amount of data across many computers in a distributed way. It is process the data at a very faster rate. The most important thing, it is reliable and the cost effective also. So Apache Hadoop is the open source for distributed and parallel processing of data, large data set using clusters of commodity low cost hardware. The advantage is it is scalable. You can easily add more nodes. It is fault tolerance, like data is replicated automatically to avoid any loss. It is cost effective, run on inexpensive commodity hardware. Flexible, system is flexible, and you can say handle a structured, unstructured, and semi-structured data. And open source, it is freely available, supported by the large community. So This is the basics about Hadoop.
Yes. So thank you, Professor, for explaining the technology which is powering big data analysis today. Now coming to Professor Mohit, could you please elaborate on how big data is being used in modern enterprises, for example, in sports analytics, retail operation, financial markets?
Okay. So just as a example, like say, let's say, as you said, sports analytics. So if you think about Dream 11, right, which is a platform which handles like so they handle around 120 transactions in a very short time frame. Like say, if you're building a fantasy team, when the toss is done, you can actually change that fantasy team in the last 30 minutes. So think about the load which this platform handles at the kind of towards the start of the match. So there are very peaks which come in. Then they have to draw insights from them. You have or think about a platform like Spotify, right? Spotify is able to kind of generate song recommendations for individuals. They are able to make sure that they are able to pay royalty to the singers in an appropriate platform. And we are talking about when we are talking about Spotify, we are talking about 600 million users on a monthly basis, right? So these are like, and the data which we are talking about for something like Spotify is like a few petabytes of data. So petabytes is, you can think about like 10 raised power 6 of gigabytes, right? So 1000 terabytes. So we are talking about data which is at extremely high volume, and it's also coming at a lot of speed to us. So there's velocity, as Professor Pulkit was talking about. So it's got variety now. So with generative AI coming in, with technologies like DALI and other things coming in, you can generate images, you can generate videos. So the nature of data is expanding. The variety of data is expanding. The speed is increasing. The volume is increasing. So modern enterprises are faced with this challenge as to how kind of they can manage this data. So one of the things which has most recently happened, a trend which is coming up, is that in earlier, like say, people used to do on-premise installations of their data on their platforms, and there's a question as well on the Q&A, that can we do this economically in the cloud? Yes, we can. That's the way the technology is moving. That we have like Google Cloud Storage now being used directly, or like say S3, which is a data lake. So now there's a new concept called lake houses. So lake houses is like combining data warehouses, which were the traditional technologies, like say a BigQuery platform of Google or Snowflake's platform. So these are data warehouses. When I say data warehouses, they're basically kind of looking at a structured data which has been kind of fed into their system, then drawing insights. So but now what it is coming to, what people need is even more speed. They directly want to work on the data which is stored in data lake. So that's the new concept of lake houses, which is coming up, and especially very popular with like companies like Databricks, etc., which are like popularizing it. So most of the cloud solutions now have this concept where, like say, they can use an open source a lake house, as they call it, and then they can kind of integrate it with their own data lakes and then draw insights from them at scale. And then also new upcoming applications like generative AI, etc., are kind of driving a need for a lot of this modern infrastructure. So I hope I answered your question.
Yes, Professor Mohit, that was great. Like you very well explained the applications of big data in today's age. Now let us come to the challenges and as well as like the implication or importance of generative AI. So I will be asking questions like first to Professor Pulkit, followed by you. So first, Professor Pulkit, like what are some of the key challenges organizations continue to face, like issues like data privacy, interoperability, or cost optimization? Could you please elaborate on
Okay. Thanks, Professor. Professor, there are various challenges faced by the modern enterprise in using big data. So you can say it is a key topic to understanding that what are the challenges faced by the industries. So even through big data brings massive opportunity, it also comes with a serious, you can say, technical, organizational, and ethical challenges also. So first challenge is that data volume and scalability. So it is a challenge for the enterprises that generate enormous amount of data from IoT devices and social media, sensors, and various online transactions. So there is a problem that there is a traditional storage systems can't handle this volume efficiently. So there is require scaling infrastructure on premises or using cloud also. So can be but this process, you can say, it is expensive. So example, a retailer collecting petabytes of customer data struggle to store and process it daily. Second challenge is the deals with the, you can say, with the velocity, data velocity, the speed of generation. The modern system generate data in real time, like financial transactions, social feeds, is live streaming. So there's a problem processing and analyzing the streaming data instantly require the high performance frameworks. So these are the you can say, like there is need to use the two frameworks like Kafka, Spark for handle the streaming processing streaming data. And many enterprises still rely on the batch processing, leading to delay in this process. So example like delayed fraud detection in banking due to slow data pipelines. Another challenge is the type of variety that challenges big data comes in many forms: structured form, data, semi-structured and unstructured data, like in the form of video, audio, logs. So there is a problem in integration. These different kind of types into a single analytic system is complex. It is very complex. So many legacy tools can't handle non-tabular data efficiently. And the example of this, combining text data from social media with the transactional database for customer insights. Next challenge is the data integration. So challenging is often stored in separate systems like departments, clouds, legacy servers. The problem is too hard to unify and can't get a single version of and inconsistent format, duplicate data. These are the problems. And for example, sales and sales, marketing, and customer tech support team, each they maintain each maintain different customer data set. Sometimes that like take another example, like once you have many of us receive a call from various say organizations like Policy Bazaar and some different banks, like they offer the card services and you deny. But still next day you will receive a call again, because it is difficult for them to maintain the data again and again. So they have the multiple number of employees, they have shared the files. So these are the challenge. Another challenge, most important challenge is current word, is the data security and privacy challenge. It is the, you can say, data is the most sensitive part. So data of the individual, personal data, health data, so that must be protected. You there is a risk of data breach and cyber attacks. Compliances with the privacy laws is also there. So healthcare provider using the patient data must ensure that it should be encrypted. So there are various these kind of challenges to with big data.
Okay, okay, great. Thank you, Professor Pulkit. So, while we talk about big data, we often hear about the five V's: volume, velocity, variety, veracity, and value. So, while Professor Mohit explained the value of big data, the applications, you nicely summed it up how the challenges arises from the volume, handling the volume, variety, velocity, and the veracity aspects. So now coming to Professor Mohit, perhaps you can close this section by reflecting on how generative AI is now influencing the big data space, particularly in data synthesis, summarization, and automated decision systems.
Okay. Yeah, that's a very interesting question, Saikat. So generative AI, let's think about like how is like data, big data was probably the facilitator for generative AI. Like these generative AI models are all built on like very large data sets. So storing them, etc., was the responsibility of the big data ecosystem which we have. Then all of these tools use some sort of parallel processing for building these or tuning, fine tuning or pre-training these generative AI platforms. So that's one bit. And then increasingly, as things have evolved, like as these large language models or generative AI platforms have evolved, what is coming to the fore is that it's not always about the volume of data, but the quality of data. So a lot of, like, say, a lot of work which is happening in the industry now is to see how good quality data can be built. And it includes like synthetic data sets, as probably you were hinting to. Like, so building, so a lot of work which uses these data platforms is to actually synthesize data and generate data sets which could be very useful for training and fine tuning these models. Right, that's one part. And then there's a lot of work which like a technology like what we talk about, PySpark, which we also talk in our course as a core part of our big data course which we run with Coursera. So a lot of work in terms of how we can actually at scale kind of clean this data and do all of that work is very useful. That's one part of it. Then there's like the usefulness of using applications which are built on top of it. So there's lots of things which are happening around, like retrieval augmentation generation, where we are talking about setting up vector databases. So a lot of new work on big data is around how do you integrate these existing systems with vector databases or into the RAG ecosystem, so that the volume of data which is already been stored onto these databases can be made useful for answering people questions through chatbots or other like insights, or using them in their summarization and generation of new type of data. And then obviously this all of this will lead to a kind of a very high ramp up. About like generation of new data will only increase from here. And especially with these multi-model capabilities available in most of these models, now you can actually generate video or draw insights from these video. So one of the things, like say, if I were thinking about like a cricket or a game, like a sports event, like now based on whatever has happened, you can actually go analyze these videos and ask a large language model to probably give you some insights from that. So all that is now available readily to us. Like anybody can use the Google AI Studio to kind of play around with that, and so that's the kind of new stuff which is happening, where I would say that the big data and generative AI are like a symbiotic relationship, where one is feeding into the other, leading to the growth of both these technologies and platforms.
Yeah, thank you, Professor Mohit. Generative AI is definitely changing the whole game here. So now let's connect back to the learning experience at JGPS. So, Professor Mohit, could you share how courses on big data and related technologies are structured, and what kinds of tools, cases, or applied projects students will get exposure to through this?
Yeah, perfect. So we've like say there's a question as well in the chatbot that do we teach AI, etc., or is it relevant to talk about big data technologies in a business analytics course? So I would strongly say yes. And one of the most like say one of the courses which we have been running successfully for past 3 years is the big data course. The big data course kind of takes you through this journey as we have been talking about. We discuss how Hadoop came up, what is the basis of Hadoop, how MapReduce works, which are very basic technologies which help us to really understand as to the challenges which big data throws up and how they were overcome in that in when Hadoop etc. yes kind of came up. That's one part of it. Then we also talk about the entire ecosystem of Hadoop. So in big data technologies, it's a zoo out there. And I mean, literally, the names of all of these platforms are from the animal kingdom. So there is Hive somewhere, there is Pig, there is Hadoop itself is like a name which was given to an elephant of duck cutting, who's said to be the founder of big data. So zookeeper, etc. So these are small bits which, if you understand these technologies, they're not very earth-shaking technologies, but if you understand the entire ecosystem, so probably your conversation when you're dealing as a business person with the technology teams could go to the next level. And then you would also understand and appreciate the logic of choosing these technologies. So we that's the first part of the course which we have. The second part of the course is more next generation, where we talk about this tool called PySpark. And PySpark is a great platform for actually building real-time analytics system, which Professor Pulkit was talking about, where we are talking about streaming. So you could make insights about data as things are flowing in. So if suppose coming from a financial market and example, you could probably see trends in what happened in the last 10 minutes and compare it with trends which have happened before the next 10 minutes or hourly candles, etc. So there's lots of work which can be done in real time processing of data which is flowing in. So you can think about marketing applications where you can do, like, say, sentiment analysis. You can be a political analyst and look at how different topics are being discussed as in like real time and probably have responses to it at the end of the day. So these are like humongous technological advancements which have happened, and we talk about all of this in our course. We kind of give you right from the legacy to the next generation. That's what the course design is at our end.
Yeah, thank you, Professor Mohit. Actually, already, if I look at the question and answer section, a lot of questions have been asked, and a lot of questions are around this, the expectation from this course, and you beautifully explained how what the students can expect from this course and why this course is so important and relevant in today's age, and why they should pursue this.
Yeah,
So we
Professor
are
Saikat,
come,
if I may just add something.
please,
So,
please.
so one of the things which people who are coming from a non-technical background have like a thought that can I learn something so advanced, etc. So I think the course is laid out such that you can, over a period of the duration of the course, be able to ramp up on all of these technologies, at least have the basics of all of this, and then finally we have end term exams, which are more like project assignments or capstone projects, where you actually go through choosing one data set of your own choice and then looking at that data set and then putting together some sort of insights based on that big data set. So that gives you kind of the rigor to kind of take that experience into your work.
Yes, yes. So thank you, Professor Mohit. So we are reaching the concluding section of this discussion, after which we will actually open the floor for question and answers. So let me ask the last question to Professor Pulkit. What kind of career pathways and research opportunities can students look forward as they build expertise in big data and analytics?
Okay, thanks, Professor Saket. Uh, so, uh, a student can gain the ability to collect, process, analyze, and interpret the large and complex data sets to make the meaningful and data-driven decisions. And this knowledge will open the doors to high-demand careers, modern technical skills like real-world problem-solving abilities across industries like finance, healthcare, marketing, logistics, and technologies. So, after studying big data, the students are expected to gain technical, analytical, and problem-solving skills such as there is data management, programming, and they can able to visualize the data visualization, statistical, and they can also perform a statistical analysis, and they are machine learning, cloud computing. So these are the points that I think they should easily able to understand about these kind of techniques, how to manage the data, understand data visualization techniques, how to do statistical operations, how to apply machine learning techniques. And the real world also have a certain expectation that students should able to apply their knowledge in a real world business and social media platform, so they can easily able to work with real-time uh, data from that is collected from different sources like IoT, social media, and sensors. So these are the points, and they can also use the ML techniques like in their code if they want, so to analyze and process the data efficiently. So these are the things.
Okay, thank you, Professor Pulkit. So, thank you both, Professor Mohit and Professor Pulkit, for the enlightening discussion. We are in the last 15 minutes, so let me open the floor for a few questions from our participants. I can see that the chat box and the question answer section is already flooded with questions. So while the participants write their questions, let me ask a few. There are actually a lot of questions related to the which I think the Coursera and the team can handle, like about the number of hours and the requirements about the course. But let me pick and choose some questions and ask to the panelists, which they can explain. So first, I can see a question has been asked that what is the difference between data mining and big data? So professors, can you please explain?
So Pulkit, do you want to go ahead?
Yes, Professor Mohit, you can continue.
Okay, so data mining is just a subset. Like I will say, data mining is something which you kind of, if you have a data set, it could be small data or big data, and you're trying to draw insights from it, trying to explore what are the kind of what are the kind of insights you can draw from it, or probably building a model to predict something out of it, or probably thinking of a optimization scenario and thinking of what you can do, how to optimize your response to the insights which you have drawn from data. So that's what is data mining, which is typically something which we teach as you like in the first probably the initial part of the course. And if you I mean, think about as analytics, right? So analytics has like three parts: exploratory, predictive, and prescriptive. So this is what essentially a data mining is about, right? And while big data is about something more, it's like about having an entire infrastructure which kind of handles the five V's which we've talked about in the course. It's about actually having some sort of parallel processing paradigm, which is like a completely different paradigm in terms of how you can draw insights from them, or kind of think about how, like, say, a Spark system is able to handle data which is coming in at a lot of velocity. But in the end, towards the big data, the final part is actually being able to draw insights from it. So what we do in the big data course is to take you through this journey so that you understand these like the basics of how you handle big data, and then be able to do data mining on top of it. But when you're doing data mining on top of it, you are actually working with tools for to which to you as a user it would look like as a normal data mining tool, but beneath it it will be actually working on a cluster of computers. It'll be using like resources optimally to make insights at scale and at great speed.
Okay, thank you, Professor Mohit, for explaining that big data is much more than data mining. It's like the application and so many things going to it. So I can see that there are some questions like around the number of contact hours and can the period to complete the program be extended and all. I think the team can handle those questions. So let me go to some other questions which are relevant for the panelists. So I can see like a question, similar type of questions have been asked, like how to use data in government systems. It has been asked by Al Yusuf, and similar question has been asked by Abhishek, that how do companies use big data in decision making, especially in India? So professors, can you kindly really give some
Okay.
examples?
So, Professor Saket, I like to answer the this question. Like, you can first, it is not necessary that you can use data in government sector. You can use data in various sectors, but in government sector, you can use the data in policy making and planning. The government can use the data to make more evidence-based decisions rather than relying on intuition, outdated assumptions. So, analyzing employment data to design better job program, using demographic data to plan schools, hospitalizations, or transport routes. Public service delivery, like data helps improve efficiency and responsiveness in our day-to-day operations, like predicting healthcare demand to allocate doctors and equipments, using real-time data to manage the traffic signals with the to manage congestions or public transport schedules. So next point, you can consider the like transparency and accountability. The publishing open data build trust and public engagement, like open budgets and spending dashboard let citizens see how tax money is used. So another sector is the fraud detection and risk management. Data analytics can detect anomalies or suspicious pattern, identify fraudulent tax claim, welfare payment, spotting procurement irregularities or corruption risk. And they can you can government in government sector they can also use the data for crisis management and public safety, like during emergency data support real time decisions. One of the example is COVID-19. Many government use the data, use these kind of techniques to deal with the pandemic situation. Like before that, we have used the word for smart city development that it is sustainable. But after COVID-19, we can say a smart city should also have the have the resilient ability also. Okay, so there are various ways the government can use the data. These
Okay,
are the
thank you.
examples of them.
Yes, thank you, Professor Pulkit. So another question is around like what are the top skills required for a fresher to get a big data job? I think many participants will have this in their
I think so. If I look at one skill which is like never gonna get you wrong is SQL skills, right? So all of these, even big data systems, are increasingly, although they are increasingly providing you natural language interfaces into them, but even now, like say even Databricks or Snowflake or any platform has SQL support, and SQL support, so SQL is one of the key skills. Then learning Python, etc., would be helpful, because if you have to use a tool like PySpark, you would have to probably program it and then probably be able to use it. So the two skills which I would talk about from a implementation perspective are like SQL and Python, which are really essential. But as you move at the higher levels, right, we are talking about concepts like data as a product or data mesh and data fabrics, which are like more architectural skills or governance skills. So if I look at like say they are so you have to be able to understand like big architectures or be able to kind of put up processes which can govern your data much better. So so they're available skill sets, like they're available positions across a lot of sectors. And now with generative AI coming in, obviously there is a lot of demand for people who can set up data pipelines for retrieval augmentation generation, or be able to fine tune these RAG pipelines so that you could have better responses from them, or be able to do data engineering properly. And data engineering has a lot of opportunities, and in terms of how you can clean data and then probably make it more useful for analysis. Although counterintuitively, the analysis takes only probably 10 to 15% of the efforts. It's like the remaining part is the governance and the making the data set useful or making it more viable. So preparing data has a lot of opportunities, and then drawing insights from it, and being able to kind of query it and make it useful for your organization in terms of the business goal which you may have. So they're like a gamut of opportunities and skills which you can build.
Okay, thank you, Professor P. So there is another concern which actually some of the participants have asked, like around how much maths or statistics is required to be successful in this program, and are the like courses quantitative enough for the data analytics, like for them to be successful in this field?
So Pulkit, you would like to take it? So in my I've seen a lot of people come out of the program, and not and everybody struggles with that feeling that they don't have like adequate mathematical background. Although mathematical skills are important to probably grasp about the internals of these technologies, or if you're working on enhancing these algorithms. But as a user, as a business analyst, or somebody who's going to use these technologies, the math skills are not very essential, as you can probably get around understanding the intuition about what is happening, and then take your knowledge from there, because there's so much to learn in terms of the technologies itself, that and I don't think this is an engineering program that you need to worry about how I improve some of these technologies. You're users of technology, so maths, although definitely a good background in maths is always helpful, but I don't think it's a prerequisite for the course.
Thank you, Professor Boyd. That's quite assuring. So yes, that's true. Like in big data and analytics, it's maths is important, but it's not everything. So let me take the last question because we are almost at the end of the discussion. So, what are the most important programming languages to learn for big data career to build a career in data analytics?
I think most important one is you should be there is Python. You can use the Python for various data analytics process like to understanding. I think if they are because Java is also necessary, but I think it is difficult for them to learn the Java for everyone. So I think Python for your is for big data programming. So I think Python is sufficient for them.
Okay, thank you, Professor
Like
Pulkit.
because
Yeah.
Python can help them to apply statistical analysis and machine learning techniques also they can use with Python. So for they can interpret and communicate result of data visualization.
Yes,
So
Professor
rest
Pulkit.
Professor Mohit, you can also give
Yeah, I
your
mean, as I
opinion.
said earlier, Python and I think SQL is very underrated. Having
Hmm.
good SQL skills will always be very useful. So if you have a good background in terms of how the schemas are designed, how the tables are there, and how you can query data out of it, it'll be useful both in the small data world as in and also in the large data world.
Yes, so thank you, Professor Mohit and Professor Pulkit. That will actually give the participants like an idea about what to expect and what to learn. So that would be a good starting point for anyone who aspire to build a career in data analytics and big data. So with this, there are a lot of questions I can see still in the question and answer section. Like, are there statistics on the number of applicants for MBA in business analytics degree that come from United States and all? So I would request the participants to come up with their follow-up questions to the team. There is a great support team here. We have Manisha and all. So Manali and Vitesh with us. So please reach out to them, the Coursera team and Spock from the GGPs. They would be definitely able to help you with their queries and what next steps to take. So with this, we had truly had an insightful session today, exploring how big data continues to evolve from its foundational architectures to its modern AI-driven applications. My sincere thanks to Professor Mohit Bhatnagar and Professor Pulkit Tiwari for sharing their expertise, and to all our attendees for joining us. On behalf of Jindal Global Business School and the Coursera team, thank you for being part of this conversation. Stay curious, stay data driven, and we look forward to seeing you in our upcoming masterclass webinars. Have a great evening. So let us close this session here. Thank you so much.
Yeah. Thanks,
Thank
Professor
you.
Saikar.